So the series of videos, we are talking about some special functions. We have already talked to you about even function, odd function, as well as periodic function. In this one, I'm going to talk to you about equal or identical function. So let's get started with a very simple example, right? I'm taking fx equals to x by x and gx equals to 1. Let's see something very interesting. If I just cancel these two x's, you will get 1. So the obvious question is, are these two functions identical? So let's look at what we have done already. So we have cancelled x. As you know from the cancellation property of real numbers, that x is going to be non-zero. So somewhere down the line, even if we found out 1, you know that there are some restrictions. Now formally, if you look at the first function, the domain will be the entire set of real numbers except for the point 0, because this is not defined. Whereas if you look at the second function, this is nothing but a constant function. So this has the domain R. So you notice that they don't have the same domain. So maybe they're not identical. So let's see what we actually need, what properties we need for two functions to be equal or identical. First of all, their domain have to be the same. They should have the same codomain. And also this part is very crucial. Under both the functions, the input, if the input is the same, the output is going to be the same. All right, so then only we will write f equals to g and call them equal or identical. Let's take some examples then, starting with the most basic thing. You have to explain whether they are actually equal or identical or not. If you have to say that they're identical, you have to check all the properties. If not, what's the reason? So if you just look at the gx, this is root over x square. So this is only giving you positive, rather input, if this is 0, it's only giving you like non-negative output. So this is basically mod x. So if you look at x, like the fx equals to x here, which is the first function, this is the identity function, which is entirely spanned over R. So somewhere down the line, you have a clue that maybe they are not identical. Take an example. Suppose I'm taking f of minus 3. So the output will be minus 3. Whereas if I take g of minus 3, this will be root over 3 square, which is root 9, which is 3. Note that we have taken the principal square root because this is a function. It cannot have this, plus minus 3 in two values, etc. So clearly, they are not identical. Take the next one. Now, as you look at gx, you understand that this is sine square x plus cos square x, and from the basic things we know about trigonometric functions, we know that this is going to be 1. So they're essentially the same function. Another example. So on many occasions while talking to about the properties of logarithm, we write log of x square as 2 log x, etc. So apparently you might feel that, okay, they are the same, but let's see what kind of things we can have here. So whenever you have this ln x square, you can have any input of x except for 0. So you need logarithm of something, that something has to be positive. So you cannot take 0, otherwise it's perfectly okay. But if you consider the next one, ln x, it has to be defined only for x greater than 0. So somewhere down the line, you understand that they have different domains. So they're not identical. So whenever you have to check whether two functions are identical or equal, check all the possible things you need. Even if you find one such possibility where the domain or codomain or the functional value is not coming out to be the same, so they're not identical. I hope you understand the definition and the applications. So that's it from the series of special types of functions. In the next few videos, we are going to talk about more, concepts about functions. So stay tuned.